DNA replication is semi-conservative, whereby each newly synthesized strand preserves one original template and acquires one newly formed complementary strand. As you can see here, I have two seeker here. Above is the old strand. It already have complementary base pairing, and the zipper below is the new strand. In the double helix, there are two types of strand. The continuous strand or the leading strand, and the other one is lagging strand. The continuous strand or the leading strand starts from the 5' to 3', and the lagging strand starts from 3' to 5'. Why is it called the lagging strand? Because every unzipping, every time that we unzip the double helix, it blocks the hydroxyl group. It blocks the hydroxyl group. So this one, why do we call it the leading strand or the continuous strand? Because there is a continuous, the complementary base pairing, continuous base pairing of the nucleotide. Here in DNA replication, the strands are anti-parallel to each other. It means it runs the opposite direction. We are not calling it from right to left or left to right. Instead, we are calling it from 5' to 3' or 3' to 5'. So here, I'm going to show you the nucleotide sequence. The color pink is cytosine. The complementary base pair of the cytosine is guanine. And the blue one, the guanine is green. The blue one is adenine, and the complementary base pairing of adenine is thymine. This is the color yellow. It goes same with the other nucleotides. So, did you know what holds nucleotides together? It's the hydrogen bonds. The hydrogen bonds are between the two nucleotides. Here in cytosine and guanine, there are the presence of 3 hydrogen bonds. While here between the adenine and thymine, there are the presence of 2 hydrogen bonds. Before the first event will happen here in our double helix, there is a need of DNA gyrase. The purpose of DNA gyrase is to relax the supercoiling of the hydrogen bond. We need to put it right here. And now, we have here DNA A, DNA B, and DNA C, or what we call the helicase. The purpose of helicase is to unbind and zip the hydrogen bond between base pair. So we're gonna put it right here, and this is the first unzipping. And we're going to stop here. We need to unzip the old strand and the new strand. And here comes the DNA B and DNA C here. There is also a need of SSBP. SSBP purpose is to stabilize the open conformation. So we need to put it here. It will stabilize the open conformation. And the next thing will happen is the DNA polymerase 3. Before the DNA polymerase 3, there is a need of RNA primase. The RNA primase will catalyze the RNA primer. So the purpose of RNA primer is to generate the OH group. Now here comes the polymerase 3. We're gonna put it to one nucleotide here in the lagging strand. So the polymerase 3 can now add the nucleotide. We're going to put the complementary base pair of thymine. Thymine is to adenine. And adenine is to thymine. And the other one is cytosine is to guanine. Adenine is thymine. Thymine is to adenine. Here comes now the second unzipping. Second unzipping is coming. And we need again the SSBT to seal the open conformation. The second unzipping is done by the helicase, the DNA B and C. So here. This is the leading strand or the continuous strand because it starts from 5' to 3'. So now we're going to do is to put the complementary base pair continuously. Guanine is to cytosine. Adenine is to thymine. Thymine is to adenine. And guanine is to cytosine. Here in the lagging strand, we cannot put the nucleotide continuously because it requires another primer. The 3' blocks the hydroxyl group. That's why we need the RNA primase to catalyze the RNA primer. We're going to put again the RNA primase that will catalyze the RNA primer. So here comes the DNA polymerase 3 to add the nucleotide. And now we can add the complementary base pair of each nucleotide. Thymine is to adenine, and adenine is to thymine. Cytosine is to guanine. The next event that will happen is the termination of RNA primer by the use of DNA polymerase 1. We're going to put it right here first to terminate the RNA primer. Using the DNA polymerase 1, and now we're going to fill the gap with the complementary base pair of the guanine. The complementary base pair of guanine is cytosine. So here we're going to put the DNA polymerase 1 here, and there is a need of the presence of DNA ligase to seal the gap. So the purpose of DNA ligase is to seal the gap between here from the RNA primer, and we're going here next to the second RNA primer. It will terminate also the RNA primer by the use of DNA polymerase 1. And now we terminate the RNA primer. The next thing will happen is we need to fill the gap with the complementary base pair. The complementary base pair of cytosine is guanine. So here we also need the presence of DNA ligase to seal the gap. And that's all. This is the end product of the DNA replication, which is semi-conservative mode. This is the old strand here and here, and now this is the new strand here, here, here. Old strand outside and the new strand inside, and here is the continuous strand or the lagging strand, and here is the continuous strand or the leading strand, and here is the lagging strand. Thank you.